name is Dr. Hadas. I'm the founder and author of Nitromedicine, and I'm on my team of doctors. Dr. Weber, he's here. Michael, Dr. Norm Shelley, he's a retired neurosurgeon. He's a first surgeon who placed the spinal cord stimulator in the back. We have Dr. Garish, who's here, right, somewhere. And Dr. Michael Hamblin, he's a Harvard medical professor. He's a pioneer in photomedicine. And Dr. Albert Ray, he's a pioneer in integrative medicine. And I think he's doing very good in cognitive therapy as well. So what is nitromedicine? It's a new specialty that focuses on managing chronic disease or diseases and restoring the nitro-redox balance. And I'm trying to emphasize on a very important concept before we go into the whole detail here about redox potential versus pH. It's very important that our doctors need to take the redox potential and consider it as a very important concept to translate all kinds of alternative medicine, whether it is photo or electro or sono, that they work through modulation or restoring the redox potential homeostasis. And I know redox potential concept is not yet in the medical books. We have the pH, yes it is, which is acidic and alkaline, and it does affect the acute conditions, the ER conditions, and we are very working on, when we work on restoring it as part of managing of all these acute conditions. But in chronic condition, really the player here is redox potential. And what's the difference between redox potential and hydrogen potential, which is the pH? Redox potential is the tendency of the substance to attract electrons versus hydrogen potential, which is pH, which is the tendency of the substance to attract protons. And so I think when we are going through the slides, we will have more understanding about redox potential and how it's controlling the cell cycle, the genetics, the apoptosis, the anti-apoptotic genes, the antioxidants, circadian rhythm, cardiac rhythm. All of this, you will see, it's all regulated by the redox potential. Now, we mentioned that by restoring the nitro-redox balance, we can manage all kinds of chronic diseases, whether it is degenerative, autoimmune, chronic inflammatory, chronic infectious, pain conditions. And why? Because all of them, they share a common thing, which is increase in the pathological free radical and decrease in the nitric oxide bioavailability. I call this nitro-redox imbalance. That is what they share, right? Whether it is the disease that affects the heart, the myocardial infarction, angina, or the disease that affects the skin, psoriasis, dermatitis, rosacea, whether it's affecting the joints, rheumatoid arthritis, osteoarthritis, whether it's affecting the lung, asthma, or COPD, whether it's affecting the immune system, the brain, Alzheimer, Parkinson, autism, migraine. All of them, they share a common thing, which is an increase in the pathological free radicals and decrease in the nitric oxide bioavailability. So, how we manage these diseases? By restoring the nitro-redox balance. We can slow the progression of these diseases by just restoring the nitro-redox balance. In fact, some of the conditions we can completely resolve it and manage it, like complex regional pain syndrome. It's completely resolved and managed by photomedicine and nitrocompounding, which contains thiols and polyphenols and nitric oxide donors. And so other diseases, we can at least slow the progression of it, manage the symptoms of it, and all the therapies that we talked about, whether it is regenerative or integrative or functional, ultimate mechanism is restoring the nitro-redox balance. So how we diagnose oxidative stress-related disease, and that's what we call those conditions because they're sharing a common thing, which is high pathological free radicals. We call them oxidative stress-related disease. So how we diagnose oxidative stress-related disease? We find out that with patients with oxidative stress-related diseases with high pathological free radicals, it causes shortening of the telomeres, right, by oxidation. It also can affect autonomic nervous system. Autonomic nervous system is very sensitive to the pathological free radicals. High pathological free radical, low nitric oxide, cause sympathetic overactivities. So what keeps the check on the sympathetic activity? Nitric oxide. Nitric oxide does inhibit the sympathetic overactivity or keeps it down, puts the checks on. So when you have high pathological free radicals and low nitric oxide, what would happen? You would have sympathetic overactivities. Sympathetic overactivities cause stimulation of a NOx enzyme, and NOx enzyme cause release of the free radical or produce free radicals, which you will end up with that vicious circle, right? Well, free radicals will consume the nitric oxide, causing sympathetic overactivities, and sympathetic overactivities cause stimulation of NOx, NOx cause generation of free radicals. So you end up with that vicious circle. So we find out that autonomic nervous system are very sensitive to the pathological free radicals. In fact, the high pathological free radical can cause destruction even for those unmyelinated nerves because they're very sensitive, and leads to autonomic dysautonomia. So we can use the ANS testing to diagnose the nitroredox imbalance or the oxidative stress related disease. Also, we can use the endothelial function test. Did you hear about the endothelial function test, right? Endothelium that lines the blood vessels are very sensitive to the free radicals. And if you have high pathological free radicals, you will have endothelial dysfunction, and you can test it by endothelial function test. So if you have abnormal endothelial function test, that means you have abnormal nitroredox balance or nitroredox imbalance. What that means is because there is underlying chronic oxidative stress-related disease, and all those diseases can lead to this. So we can use this diagnostic test to diagnose, to monitor the efficacy of the treatment, and also to monitor the progression of these diseases. So how we manage oxidative stress-related disease? We manage it by using nitroredox modulators. Those are the ones who can restore the nitroredox balance. Whether it is biological, stem cells, plasma, rich platelets, hear about probiotics. And we know that the stem cells, the plasma-rich platelets, they are rich with thiols, the nitric oxide, the growth factors, and the growth factors gene, and cytokines, and redox enzymes, and they can restore the nitroredox balance, right? Stem cells, not necessarily will give you that replacement effect, but it can give you a trophic effect due to the contents of those stem cells in PRP. The other way we can restore the nitroredox chemically using thiols, which is glutathione, lipoic acid, nitric oxide donor, polyphenols, ozone, hydrogen, carbon dioxide, 6-hormone, antioxidant enzymes, cytokines, vitamins, and detoxifications. The third one, which is the energy nitroredox modulators, which I think we just spoke about it, light therapy, sonotherapy, electromagnetic therapy. All of them, they help in restoring the nitroredox balance. And then we have the psychotherapy, nitroredox balance, which is cognitive therapy, holistic therapy, yoga, spiritual. And how that happens, especially for psychotherapy, we know that if you are able to improve the mood by cognitive therapy, the sympathetic tone goes down. If your sympathetic goes down, what's happened? Your free radicals goes down, right? Because sympathetic is a pro-oxidant, parasympathetic is antioxidant. Parasympathetic is anti-inflammatory, sympathetic is an inflammatory arm. So if you're able to balance the autonomic nervous system by the cognitive therapy, it's part of the management of the oxidative stress. Energy therapy that we saw, all of them, they work with this common thing. They increase the physiological free radical level. They cause a spark in the physiological free radical, then that will cause a stimulation of antioxidant genes, anti-inflammatory, anti-apoptotic genes. That's why Dr. Albert, he said, the effect will take days and weeks because you're working on increasing the expression of the genes of anti-inflammatory, antioxidant, anti-apoptotics. You're not working on scavenging the free radicals. It's not like giving aspirin to block the COX. You're working on stimulation of epigenetics now. And that's the way we can relay our approach to the mainstream doctors. Mainstream doctors, what they want? They want to know how it works. What's the mechanism of action? They accept aspirin because it blocks the COX enzyme. So how acupuncture works? Acupuncture, when you are putting your needle, you are causing tear and some sort of inflammation. I don't want to say inflammation because a lot of doctors, especially the mainstream doctors, think about inflammation as dysfunction. Oh, you're giving inflammation patient. No. It's actually increasing a spark of the physiological level of free radicals, which stimulates the anti-inflammatory genes, the antioxidant, the anti-apoptotic. That's how acupuncture. And here, very important, that acupuncture, prolotherapy, ozone, their effect is on the healthy tissue, mainly, not the pathological tissue. So when you do acupuncture, you don't need to inject your needle into the pathological area. Actually, it may aggravate the whole thing. You just need to do it on the healthy tissue, including the waves. But light therapy is a little bit different. Light therapy can work in both ways. It buffers the redox. You can also put it on the lesion and decrease the pathological free radicals. because those excited electrons from the light therapy, they will neutralize the free radicals. The excited electrons from the healthy tissues, they will be taken by the oxygen and cause an increase in the physiological free radicals and stimulate the antioxidant, anti-inflammatory, antioxidant genes. So light therapy has double effect. It can affect on the lesion. Put it on the lesion, it works. You put it in a healthy tissue, it works. That's why we're giving it for the horse races, for even human races, to increase their endurance, their ATP production, to buffer their redox, to increase their growth factors because of their effect on the healthy tissue. Electrotherapy can also do the same like light therapy, especially the electrons. The microcurrent, not the high one, the microcurrent therapy does neutralize the free radicals, so you can put it on the negative charge, you put it on the lesion, it's okay, because it will neutralize the free radicals and buffer the redox. So, all these therapies that we are talking about, and we are preaching and trying to communicate with the mainstream doctors, which is the integrative, holistic, acupuncture, functional, regenerative, physical therapy, they all work ultimately by restoring the nitroredox balance. By restoring something is called redox potential homeostasis. Now, the mainstream doctor knows about restoring the pH, the hydrogen potential. But few of us knows about the importance of restoring the redox potential. And in chronic diseases, we fail to manage chronic diseases because lack of understanding of the importance of the redox potential and the pathogenesis of all chronic disease. Once we understand the redox potential, which is a lot of research out there, we can say thousands, we need to translate them into clinic. And of course, the big pharma have no interest to do that because they cannot contain it, they cannot patent it. Although they try to do it. But, and we're going to see it, and when we manage Parkinson's disease, you will see they're trying to do it, but they find out they fail because they cannot contain one drug, and you cannot manage redox potential with one drug, then they kind of dismiss it and move on with their big pharma products. Let's go and give an example of one of the oxidative stress-related disease that affect the nerve, which is a degenerative disease. It's called Parkinson's disease. And of course, all kinds of neurodegenerative disease does have some sort of similar mechanism. They have the sort of proteinopathy problem with recycling the waste, which is the synuclein, amyloid, but the location is different here. In Parkinson's disease, as you know, it is a chronic, debilitating, neurodegenerative movement disorder characterized by progressive degeneration of a dopaminergic neuron in the substantia nigra region in the human brain. Oxidative stress plays an important role in the degeneration of dopaminergic neurons in Parkinson's disease, disruption in the physiological maintenance of the redox potential in the neuron, induced apoptotic genes, and cell death. To date, oxidative stress is well accepted concept in the etiology and the progression of Parkinson's disease. A number of sources and mechanisms for generation of reactive species are recognized, including the metabolism of dopamine itself, mitochondrial dysfunction, toxins, neuroinflammatory cells, and aging, in addition to Parkinson's disease, causing gene products including DG1, PENG, PARC, alpha-synuclein, and LRRK2, which causes mitochondrial dysfunction, leading to leakage of the pathological free radical and susceptibility to oxidative stress. Therefore, our therapeutic protocols are targeted against suppressing and alleviating the oxidative stress-induced cellular damage and increase the dopamine bioavailability. And here is the whole mechanism of Parkinson's disease. I'm going to break it down, make it simple and easy, right? So, we find out that Parkinson's symptoms manifest after 50 to 70% of degeneration of the dopaminergic neurons. Then it manifests, right? What will happen to the rest of the dopaminergic neurons? They will continue overproducing dopamine, trying to replenish the deficiency, but it's not enough to produce that enough of inhibitory signals needed.
I'm glad you put genetic error on the top.
Right. Needed inhibitory signals needed to block the indirect pathway. and direct motor pathway. I think Dr. Will is a neurologist here. He knows about the direct and indirect. When we're trying to flex the forearm at the elbow, right? There is a motor signal that goes the direct pathway to the biceps, right? At the same time, there's motor signals that goes to the triceps. You need to inhibit the tricep to allow that bicep to go that flexion, right? So if you don't have the inhibitory factor or enough dopamine to inhibit the indirect pathway, what will happen? You get that shaky, freezing movement, right? And slow movement, which is the symptoms of the Parkinson disease. So, what is the cause of Parkinson disease? Most of it is idiopathic. Around more than 95% idiopathic. Less than 5% are toxins or combination of both. Those idiopathic, it's genetic errors, mutations. Some of the genetic errors are recognized, right? They are the synuclein, the PINK, the PARP, and DJ1, and they all cause mitochondrial dysfunction. Let's talk about synuclein. I'm very interested in alpha-synuclein because it's all about disruption of the homeostasis of the redox potential. And starting with synuclein, it's a cytoplasm protein that involved in dopamine vesicle exocytosis, recycling, storage, and compartmentalization. That's the synuclein protein function is. So if you have mutated synuclein, what happened to that mutated synuclein? They aggregate and they become protofibril synuclein, alpha protofibril synuclein. Alpha protofibril synuclein, they interfere with the normal synuclein physiological function. They stick on the synaptic vesicles. Normally, the synuclein stick with the synaptic vesicle to cause exocytosis. But once they get abnormal, they clump, they stick and they inhibit the synaptic vesicle exocytosis. So what would happen here? You would have toxic accumulation of dopamine vesicle and the terminal of the dopaminergic neurons, right? What else? This protofibril synuclein, they cause holes and pores into synaptic vesicles, which leads to release of the dopamine into the cytoplasm. And that's toxic, right? Because dopamine is toxic in the cytoplasm because it auto-oxidizes and they become oxidized dopamine, and oxidized dopamine is a free radical generate free radicals that will disrupt the homeostasis of the redox potential that leads to activation of apoptotic genes, cell death, and degeneration. In addition to that, the oxidized dopamine, we call dopamine phenones, they cyclize and they become aminochrome. Aminochrome is further free radical generator. They generate free radicals, and they start adapting, combining with lipids and protein, including the synuclein, and they form a toxic waste. It's called neuromelanin. Neuromelanin, along with protofibril synuclein, both, when the cells dies and degenerate, they will be released. Right? Who's going to take them? The microglia. The microglia, when they take them, they get irritated, inflamed, and they become what? Inflamed microglia, which is neuroinflammation, right? And the microglia, when they are active, inflamed, they start releasing the proto-inflammatory cytokines, the free radical, the reactive oxygen nitrogen species, and the reactive nitrogen species blocks the dopamine synthesis from the tyrosine, which is the tyrosine hydroxylase. They block that enzyme. So it inhibits the dopamine synthesis, right? The peroxynitrate, the other side of the nitric oxide, right? And so the other things about protofibril or synuclein, they act like prion-like protein. You know the prion-like proteins and those proteins misfolded, right? This alpha-synuclein, the mutated one, they be released outside these dopaminergic neurons by exocytosis and will be picked up by the neighborhood cells and goes by endocytosis and trigger the aggregations in the neighbor dopaminergic neurons, right? The same like prion proteins, right? And they cause or trigger the apoptosis and death to the neighbor dopaminergic neurons. What else? This protofibril alpha-synuclein aggregates of this mutated synuclein, they attack the mitochondria. They inhibit the complex 1, causing mitochondrial dysfunction. And when you have mitochondrial dysfunction, what will happen in mitochondria? They start leaking the free radical, the pathological free radicals. What will happen if you release the pathological free radicals from the mitochondria? It can cause release of the iron from the heme and non-heme proteins. Iron is toxic when it's being released. They are free radical generators. They can convert the hydrogen peroxide, the superoxide anions, to more powerful free radicals, which is superoxide radicals. And superoxide radicals trigger the apoptosis, the degeneration, and the cell death. What else? Well, those free radicals being generated or released from mitochondrial dysfunction, they can also cause opening of calcium channels from the endoplasmic reticulum through a certain type of calcium channels called L-type calcium channel, right? And they cause release of calcium. Calcium in cytoplasm in high concentration is toxic. It can toxicate the mitochondria far there. And when you toxicate the mitochondria, you end up with mitochondrial dysfunction, you start releasing what? Those pathological free radicals. In fact, toxic calcium can also cause membrane or mitochondrial membrane permeability transition, which leads to release of cytochrome oxidase itself, a combination of cytochrome oxidase, calcium, right? And including all the free radicals, they will induce the apoptosis, degeneration, and the cell death. So, when we are going to manage Parkinson's disease, is it enough to just give L-DOPA? No. You need to give iron chelation therapy to remove all this excess of the iron, right? Because they are free radical generators. So you can give
calcium chelation.
You need to give calcium chelations, whether it is pharmaceutical or natural. The natural one is Cellular. For the iron, we can use curcumin, but you can use the chemical one, the dysferoxamine, the pharmaceutical one, whatever you choose, but it's not enough just to give L-DOPA. Also, you may need to give reduced glutathione, IV, right, which helps to scavengers the free radicals. I think Dr. David Perlmutter, he has very great success. I don't know if you know him, he's in Florida, he's a neurologist, doing IV glutathione. I have a video of him, I met him in A4N, I want to invite him to be part of our work. And he gave me the permission to show his video, and I saw his video is very great, with great success using IV glutathione. But the problem is that it's not enough to give IV glutathione. You cannot manage oxidative stress by one therapy, by antioxidant monotherapy. Yes?
Have you used nasal spray glutathione?
Yes, that's what the thing that you can do by the compounding pharmacy, and I think we have a compounding pharmacy here who's listening and who wants to be creative, and he can do the IV glutathione, intranasal nano-glutathione, intranasal dopamine, which is better than oral. The reason because oral, the absorption is not that perfect. You don't get a steady concentration. You get the off and on. So now they are technology where they're using an intranasal nano-dopa or topical patch of dopamine, which is better, so you can get the steady concentration. So does that mean we're not giving L-DOPA anymore? We just empower the antioxidant capacity? No, because you have almost 50–70% of nerves being degenerated. You still need to give them some sort of L-DOPA to help them to produce those dopamine. Although the dopamine that they produce, it's toxic for them because they have a problem of recycling their own waste, the free radicals, right? That's the problem with those dopaminergic neurons. They already have waste of free radicals, and you're adding dopamine, it can toxicate more and more. And yes, when you give L-DOPA, it will accelerate the degenerations, according to the lab studies and animal studies, but they did the human studies, and they find out there's no really change in the progression of the disease if you give the L-DOPA early or late, and the reason why. If you don't give L-DOPA, then you'll be stressing those dopaminergic neurons to make the dopamine out of scratch, which is tyrosine, and that is an active metabolic process, require ATPs, and also it generates free radicals. So, if you give dopamine, it catabolizes, it gives you the free radical, it accelerates degenerations. If you don't give, you're stressing the dopaminergic neurons, and they still produce the free radicals out of the tyrosine. So, what we need to do, we need to empower the antioxidant capacity of the cells and the removal of the waste by all methods, including everything that can help to patch those free radicals. And just one second, let me just give you an example here. I have a flat tire, and I want to use an example just to show you how the free radicals can be managed. Flat tire has many holes, well, three holes. And when I took it to the car shop, he has a liquid spray soap, and he starts spraying it and finding all those holes, and then he starts patching it. If he patched one hole, it will not be fixed. He has to patch them all. In managing antioxidative stress, we know that our body have many sources of leakage of the free radicals, including the gut leaky syndrome, including toxins, including the mitochondrial dysfunction, including abnormal metabolism of drugs that you're taking, right? Maybe taking drugs and they become what? Free radical generators, like statins, including abnormal metabolism of nutrition, like folic acid, right? That's your area. I'm getting into there. And so there is many sources of this, and all of them has to be managed. So giving IV glutathione may help. You can see the video, it's dramatic improvement. But you're not getting the long-lasting effect. Even like therapy, if you give it, it may help the mitochondrial dysfunction, but that's not enough. You really need to work on all the leakage of the free radicals, including the cognitive therapy. If the patient is stressed and the sympathetic is fired up, then that generates free radicals as well, and that can aggravate the whole conditions. So we need to work on antioxidants, polyphenols, thiol, nitric oxide, enzyme to stabilize the mitochondrial membrane, calorie restriction diet, right? We just talked about it, right? Exercise, photobiomodulations. Now, the big pharma, they know there's something about working on the slow of degeneration, so they create something called psilocybin. What is psilocybin? It's an inhibition of monoamine oxidase, monoamine oxidase inhibitors. That's B. That's in the microglia, which is responsible to degrade the dopamine, right? And so when it degrades dopamine, to oxidize dopamine, it generates the free radicals. So the big pharma say, let me go ahead and inhibit that. That will increase the dopamine bioavailability and decrease the free radicals. But according to the study, it's called Diagnostics, did not show any improvement in the general progression of the Parkinson disease. Why? Because it's monotherapy antioxidant. It will not work. Like any other antioxidant therapy, like therapy, if you do it by itself, it's not going to be as effective as you are doing all the antioxidant therapies. I think Dr. Stephen did mention about all this multi-therapy antioxidants therapies, managing the gut syndrome. Still, you can do testing for allergy as well, because it can be source of free radicals allergy, so desensitize the patients. Nutritional genetics, folic acid, abnormal metabolism lead to increase in homocysteine. Homocysteine is a free radical generator, so it needs to be fixed. Pharmacogenetics, if you're taking drugs, you need to make sure it's metabolized well in the body, otherwise if it's generating free radicals, it aggravate the condition, like statin. Toxin screening, yeah, we need to screen them, detoxify them. 6 hormones, right, Dr. Garish? 6 hormones is very important to restore the nitroredox balance because they are stimulating the epigenetic of antioxidant and anti-inflammatory. Vitamin D is very important, stimulate the antioxidant epigenetics. And how we can know that we are in the right track, right? We need to have some oxidative stress markers, which I think Dr. Steve Willard did mention about them. Add to it the ANS test, well, it's a reflection, any imbalance in ANS is a reflection of nitroredox imbalance, right? And the function test is another way of monitoring the efficacy of your treatment, knowing whether you're on the right track or not. The oxidative stress markers in the urine, which is the hydroxynonal, hydroxyguanosine, oxidized LDL, all of this needs to be used to monitor the efficacy of the treatment. Now, what's your question? I don't want to lose the track.
Do you use phosphatidylcholine to stabilize membranes?
Well, whatever you think that will help to empower the antioxidant capacity and empower the recycling of the waste, give it to the patients. All the testing that Dr. Steve Willard is doing, it's actually, it may look complicated. Other doctors will say it's accessory and extra, luxury. No, it is not. Because any deficiency can affect all of your management. So you need to go through all the things that Dr. Stephen Willard is actually practicing and is actually educating us to do it, because it will help ultimately to restore the nitric ox and manage those oxidative stress related disease, including iron chelations, calcium blockers. You can use the resveratrol, curcumin. You can use it for iron chelation therapy. Do I have time? Is it still?
Yeah, about 2 minutes.
2 minutes, okay. We can just go here and then we get the questions. So Parkinson diagnosed and management is diagnosed clinically by the trap, the trap, tremor, rigidity, akinesia, postural instability. That's one of the ways to monitor the effects of treatment clinically, or you can use those oxidative stress markers. Management, main treatment, Silagilin, Pramipixole, right? But as we know, the Silagilin does have antioxidant, but it did not affect the whole process of the disease or progression of disease because it is antioxidant monotherapy. The big pharma, they try, but they fail, and they say, oh, we fail, right? But I think if you follow the protocol of Dr. Steve Willer, I think you'll be able to restore the nitric ox balance. Pramipixole, it's a dopamine agonist, and it's also antioxidant, but still did not show any effect in the progression of the disease. The other thing is very important, restoring the nitric ox balance and neutralizing the free radical generators to slow the progression of the cholinergic neurons, degenerations, and increase the dopamine bioavailability at the substantia nigra. Now, do you remember when I say up to 70 to 60% of degeneration has to happen to manifest Parkinson's disease? So why we don't genetically test all the people who has a family history of Parkinson's disease, and if they have any genetic or any indication, why we don't start doing what Dr. Steve Willer is doing in his clinic and restore the nitric ox balance and give them polyphenols, especially the curcumin. Why? Because curcumin is the only supplement that looks like Congo dye. You know Congo dye they use for staining amyloid deposit and acetylcholine. They look like them. They actually tag the acetylcholine protofibrils and detoxify them. So if we start giving curcumin in the beginning, we may able to delay the onset of Alzheimer's disease and all kinds of degenerative disease, especially if they are going to tag and detoxify the protofibrils, acetylcholine, and also the amyloid fibrils. And other polyphenols does inhibit the formation of the aggregates, acetylcholine aggregates. Yes, all the ECGC, the coffee bean extract, all others, they definitely help to inhibit the aggregation. But what attach and tag and detoxify the aggregation itself is the curcumin among all its polyphenols. So that's why I consider curcumin as the king of the polyphenols. Any questions?
The extract of cinnamon.
I think all of them does inhibit possibly the aggregation, but when it aggregates, the only thing that I know works, according to the publications, is curcumin.
Curcumin is an extract of the cinnamon.
It's extract of the turmeric.
Huh?
Turmeric. I don't know about cinnamon.
Turmeric?
Turmeric, yes.
Oh, okay, I know what it is.
Right. Okay, I think it's a
All
time.
Mediterranean
Do you
food.
have any questions?
Huh?
Okay, all of this is recorded and it's online. The other thing that I want to add, if the patient has pain from the spasm of the Parkinson's disease, or you have any pain conditions, I think the pharmacy I have here, he developed very unique nitro compounding formulations to manage pain without that much of pharmaceutical ingredient with a great effect. And again, my video records of all my presentations is recorded on the website, including Dr. Bird. It's going to be on the website as well. Nitromedicine.com. Thank you very much.
We're going to take a break.